Hi everyone, this is Mathieu from Evolute, and today we'll continue the tutorial series about EvoluteTools PRO, and we'll have a closer look at the closeness optimization to curves. There is a common use of the closeness optimization to curves that you might already be familiar with. If you want to optimize a mesh to a surface with open boundaries, optimizing for closeness to the surface is not enough. You also need to optimize the boundaries of the mesh to be close to the curves. In this case, I'm creating a flat mesh. I am fixing the corners. And optimizing only for surface closeness with all other factors set to 0. My reference is the NURB surface I defined earlier. And if I optimize, the mesh gets close to the surface, but without respecting the boundaries. And also it looks very jagged because I didn't have any smoothness optimization. What I need to do instead is to add the boundary of the surface I'm optimizing for to the references. Now that I have a curve set as a reference in addition to the surface, I'm also optimizing for the curve closeness term. I'm putting the same weight in this example, and if I optimize again, now the boundaries match the boundary of the reference surface. We still don't have any smoothness optimization, but we can easily add it. For example, fairness of the curvature of the mesh. And if I optimize again, this is what I get. Of course, you can add any other type of optimization term. Now, this is something that you might already have tried. And the reason it works is that by default, the boundary vertices of the mesh are assigned to the curve that you set as a reference. If I turn off this property like I just did, you won't have this behavior anymore. If the surface has several open boundaries, or if they're more intricate than in the current example, it might be necessary to get rid of the default behavior and instead assign vertices manually for closeness to curves optimization. You can set vertex curve points manually so that instead of assigning all of the boundary vertices, you just pick several ones. Or you can even pick vertices inside the mesh, as we'll see in the next example. When several curves are used for the optimization, vertices have to pick between all the curves that are set as a reference. As a result, it's important that the mesh is initialized correctly so that the vertices can converge to the natural curve you want them to be snapped to. Let's look at this trivial example. If I set those two lines as a reference, and if I try to optimize only for curve closeness, the mesh in between, all of the boundary vertices are gonna converge to this curve because all of them from the start are closer to this one. If I initialize with the mesh in the middle, then I get almost the behavior that I want to see. The last detail that I need to check is that instead of using the default behavior, I'm gonna select curve points and not those two on the top and the bottom. In this case, both sides converge to each of the curves that they are assigned to. Finally, I'd like to present an example where a curve is not part of the boundary of the surface. So I'm just going to create, for example, a mesh inside a circle. I'm going to subdivide it a few times. Okay. I'm going to set this curve as a reference. And I'm going to have the default boundary closeness on this time. Now if I optimize, all the boundary vertices of the mesh converge to the curve. Of course, it's going to look a little bit better if I include some fairness, like this, for example. There we go. Now I designed another curve up here, and I'd like to use it and optimize for closeness to this curve as well. So first, I'm going to add it to the list of references. And then I have to add some points to use for the optimization. As you can see, all the boundary points are already automatically added since we used the default behavior. And now I'd like to add, for example, one line of vertices in the middle to use for the optimization. Here we go. The options look good. Some fairness, I'm going to keep it. And I can optimize. Here we go. And that's it for today. There's a lot more you can do with curves, but we'll keep it for a later in-depth tutorial. As of now, thanks for listening, and if you have any questions, please send them to us and we'll do the best to help you. Bye-bye.